In this session, we're going to do an overview of OLTP, OLAP, and the archive data warehouse. The learning objectives of this video are for you to be able to explain what an OLTP is and how it's used, explain what an OLAP is and how it's used, discuss the differences between OLTP and OLAP, and explain when an archive data warehouse might be used. To start off, let's discuss what exactly is an OLTP. OLTP stands for Online Transaction Processing, and it is, simply put, a database. OLTP, or the database, is a smaller system when compared to a data warehouse, and it contains current data used for the real-time transactions that must be performed in the given company. Sometimes an OLTP can have extended data, possibly going up to about a year. Typically not going to go anything too far ahead of that. It's not designed for that. OLTPs are going to be very normalized in table structure, and they are going to be set up for smaller systems. This is definitely how normalization in smaller systems work to improve the fetching of data. This is going to be designed for efficiency and working in real time. So the normalization, the small data sets, and the table designs overall make an OLTP efficiently designed for the ability to store, organize, and fetch only the data that's required. So this gives it a very good real-time system. So an OLTP is going to be the system you have developed in order to maybe work in a retail store, maybe work in an online environment or something like that. It's going to be the system that's needed right then and there. So when you go to a department store, someone has to ring up an item on the register that's going to access a database that's at the store or somewhere on the premises or somewhere near at least, where it's storing all that information. And because an OLTP is normalized, the queries and information that is gathered can be designed to fit and retrieve only the required information due to the high level of normalization. So your OLTP, or Online Transaction Processing, is your database. Currently, in working in AdventureWorks, this is a database and the system that you are most common with dealing with. Now, what is an OLAP? OLAP stands for Online Analysis Processing or Online Analytical Processing. Sometimes changes depending, but they should always be the same. OLAP is going to be your data warehouse. And a data warehouse is where historical data is stored for statistical or analytical use in higher business management. It's very common for a single company to have many OLTPs, but possibly one central OLAP. Typically, in an OLAP, these are going to be much larger systems that can contain well over 50 years of data. Some companies have been known to hold well over 80 to 90 years worth of data. The main focus of an OLAP is storing large amounts of data, and we're talking 50, 60, 70, 80 years worth of information, but they have to be stored in a method where retrieving information for analysis is quick, simple, and easy. So OLAPs, or data warehouses, are highly denormalized, meaning their structures and tables are simplified to show the data all in one table in the most denormalized states. OLAPs are going to be found in many different domains, from healthcare to banking to IT. Some domains can only manage carrying a certain amount of data. For instance, retail domains. Retail domains are not going to hold all the data from its sales, possibly from 60 years ago. For instance, a company that's been around for a long time, let's say Coca-Cola, they are not going to be analyzing the sales they had back in 1960, 1950, anytime around there, to influence any market decisions in current day. So for some domains, it's not required that they store all their data. They might store a certain time frame, possibly a time frame based on maybe 20 years or 30 years. Other domains, on the other hand, do not have that luxury, if you would. Healthcare, banking, and insurance companies almost always keep all of their historical data. And this is due to the long lifespan of its customers. A healthcare system, banking system, and insurance system all work primarily for customers on a day-to-day basis. But these can sometimes be lifelong customers. So a bank, for instance, if it has a customer that's with the bank for over 40 years, cannot delete the last 20 years worth of records because they simply run out of room. All this information must be stored because any of it can be requested, accessed, or utilized at any given time. So these domains do not have the ability to get rid of their data. They must keep it all, whether it is for customers or possibly for tax purposes. So an OLAP is going to be a data warehouse designed on storing large amounts of information to perform analysis or statistical surveys on for upper management. Management, or those in higher positions, will use this information to make large business scale decisions that can affect a company. Data warehousing can also be used by smaller companies, let's say, to find certain trends, to find statistical information that would otherwise be overlooked. For example, retail chains might want to figure out exactly when their best items sell, what time, and how much, and how does it change. So let's say I own a grocery store and I suddenly see an increase in sales for snack foods. I might, over the years, gather that information together and then perform an analysis. And then I might figure out that the same time my sales increase is always the same every year. If I see this trend and it's constantly happening, I can then better prepare or set up to make more profitable any future occurrences that might happen within my company. This is probably one of the main focuses of data warehousing. Not only performing analysis, but using that analysis and information to try and predict future trends that would lead to higher profitability. Now, when using an OLAP or data warehouse, there are a few things that need to be taken into note. In an OLAP, you do not have normal tables such as in a database. In a database, a table could easily contain any type of information you wanted. We didn't divide or normalize table based on the data that was in it, more or less based on the information such as the columns, their relationship, and any redundancy issues. When working in a data warehouse, our focus is going to be on analysis, measurements, and statistical use. So for this, tables are divided into two sets. You will have either dimension tables or fact tables. Dimension tables will be tables in your data warehouse that store any data that's used to describe or elaborate on the measurements being performed. So let's say I'm a retail company and I'm measuring my sales. I've got to know exactly what I'm measuring, how much of it, the brand, item, product, stores, etc. Any of the data that's used to tell me what brand, what names, what company, what store. Any of this information can be considered as textual descriptive data and would be stored within a dimension. A fact table is going to be a table in the data warehouse where the mathematical or statistical information is stored for being measured at a later time. So any measurements, any analysis, or any statistical data is stored in the fact tables. This will give you the numeric values to allow you to compute or find trends, sales, and profitability. In a data warehouse, primary keys, like in the databases, can no longer function accordingly. A data warehouse is comprised of all the information brought together from various databases. Now, let's take, for example, we'll say Walmart or Target. Let's say that they have 5 different stores in a given city. Each one of these stores has 200 employees, and each one has an ID ranging from 1 to 200. Now, on an individual store level, their databases will be operating efficiently. What if all that information then was brought into a one central data warehouse to be analyzed? Suddenly now, when I use the IDs or primary keys to try and identify employees, I have 5 employee number 1s, 5 employee number 2s, 5 employee number 3s, 5 number 4s, 5 number 5s, etc., etc. Thus, my primary keys can no longer serve their original purpose, which was to uniquely identify each individual row of data. So, to remedy this issue, we have what are called surrogate keys. And surrogate keys, like their name sounds, are used to replace primary keys. Surrogate keys are often thought of as auto-incremental keys and whose data or design or purpose will only be used in a data warehouse for uniquely identifying those rows that come in. Now, just because you have a surrogate key does not mean that the primary key necessarily gets deleted. Its value can still be saved and kept in the data warehouse, but it might be given a different number or a different column name. Lastly, another thing to consider is that in a data warehouse, you have the possibility of using business keys. And business keys are going to act just like a foreign key in a database. However, business keys will enable you to use a foreign key that points to the primary key located in a table that's in your OLTP. So business keys are not a mandatory key to have in your table, but they can help you better identify and connect with the data you want to record, possibly in real time. So these are several additional features to be considered when working in a data warehouse. Now, when looking at an OLTP versus an OLAP, we should discuss some of the differences that the two get confused. It's very common for the use of a database to be misinterpreted. The most common answer most people give is that a data warehouse is simply a lot of databases all in one place. But this is definitely not the case. For OLTP, we have database. For OLAP, we have a data warehouse. In an OLTP, you may store less than 1 year of data. Typically, it can give or take depending on the company. But in an OLAP, there's a good chance to store more than 50 years of data. And this is going to be addressing how an OLAP is purposely designed. With an OLTP, we are optimized for searching data in real time in order to get and return these results of only what's requested. OLTP tables will be highly normalized to achieve this goal. In an OLAP, we are optimized for storing and analyzing data when it is needed. So the data is brought into similar tables so that our Joins and querying and amount of structures are significantly minimalized and allow us to find the data in that sense faster. Tables within an OLAP will be having a focus on denormalization. That way you can bring the data together into a central table. In an OLTP, you are less likely to have a large number of indexes or partitions. As an OLTP, the data that's stored in there and its general purpose doesn't support having index and partitions as much. Now, that doesn't go to say they can never be created. An OLTP can have indexes and partitions. However, with data that is always changing or frequently changing, having these things in place could hinder performance and cause fragmentation. In an OLAP, on the other hand, you have years and years, sometimes decades, worth of information, worth of data. And accessing it with speed is the key, not breaking it up. So in order to access and sort through these larger amounts of data, indexes and partitions will be highly sought after and recommended to improve query performance. Now, a data warehouse doesn't always have to hold every single bit of information. Sometimes you can create what is known as an archive data warehouse. An archive data warehouse is where you store significantly older data that you will no longer use for analysis or processing. This portion, or this data archive data warehouse, is something that you fill full of old data and that you can then take offline. For instance, let's say I am a retail company and I do have 50 years worth of data. However, I know that I only access or utilize the most recent 20 years of data. However, I do not want to delete or get rid of any of the older data because I don't know when it might come in handy. However, I don't want to have to pay for the storage. I don't want to have to always scan the extra 30 years worth of information, and I don't want it impeding anything I'm currently trying to do. So, to fix this issue, I can then create an archive data warehouse, which is a data warehouse that can be taken offline whenever needed. So by creating an archive data warehouse, I can then store the 30 years worth of information that I am not analyzing, that I think I might need later, and I can take that archive data warehouse and then take it offline, off of my network, off of my server, which will then free up space, reduce the amount of data I have to query, and speed up the overall performance. So archive data warehouses can be used to achieve a more optimized design. Archive data warehouses don't have any special requirements. They could be a database or data warehouse you make on a server and you simply take offline. Other times, they can be completely separate systems connected on the network, and then you take the system offline. Overall, an archive data warehouse is any system holding significantly older data that can be taken offline and not worried about. Please take note of any questions you have, and they'll be answered in the Q&A portion of the training. So to summarize from the video, you should now be able to explain what is an OLAP and what is the OLTP. On top of that, you should be able to discuss the differences between a database and the data warehouse listed, list some of the new features that you would find in a data warehouse, and then explain what exactly an archive data warehouse is and how it can be used. Thank you. This has been Module 3, Session 1, OLTP versus OLAP.